I am Cindy Berrie. I am a professor in the chemistry department. I grew up in this part of the country. I grew up in Nebraska, got degrees from the University of Nebraska in chemistry and math, a physical chemist. I did my PhD at the University of California at Berkeley, doing reaction dynamics, followed by a postdoc at the University of Colorado at Boulder with Steve Leone, growing semiconductor materials. So I am a microscopist. We look at materials and the interfaces of materials, particularly how nanoscale structure of those materials affects their properties. So over the years, that's included things like electronic properties, adhesion, friction, biomolecule, peptide, protein binding, organization of enzymes at interfaces. So through that work, we've worked with a number of collaborators in, say, physics and engineering and biology who know how to grow these materials or to make and express peptides or proteins, that sort of thing. So our students in my group get a wide variety of experiences in a number of different fields using common tools so that everybody can kind of work together. So we have a nanofabrication facility. Obviously, some of my group has been interested in using those kinds of tools and instruments and have been using some of that sort of capability. We've also taken advantage of the microscopy and analytical imaging lab to do electron microscopy and things like that. Students in my group have one part of these larger projects in one of these areas, whether it's nanofabrication or whether it's protein or peptide binding to surfaces or electronic properties of materials, but they work together with other students and they design the experiments to answer the questions that we're trying to answer about how these materials behave and what their properties are. But they take an active role in designing those experiments. They mentor undergraduate students, but they sort of help design their own projects and they carry out the work and write the papers, and I just sort of answer questions and lead things. Students in my group typically collaborate with either someone in, say, bioengineering or molecular biosciences on the protein or peptide work, or on the materials work we might collaborate with Misha Berabin, who's a synthetic and organic chemist, or Judy Wu's group in physics, who does condensed matter physics, and working with her students. We've also had students work on a number of projects where we've collaborated with other condensed matter physicists on some of their electronic materials properties. Students in my group have taken a variety of different career paths. I have students who are in the pharmaceutical industry. I have former students who are in the semiconductor industry, working at places like Intel. I also have some former students who are in, say, defense contracting, working on materials projects there. I also have a number of students who have gone into academia, who are teaching at primarily undergraduate institutions, things like that. So, wide variety of backgrounds from students and a wide variety of interests, so they do a variety of things when they graduate.